Hi, this is Mrs. Vaughn, and I want to give you some examples for tangents and secants and the angles that they form. Let's go. Okay, so this is the same slideshow that I used to give you your notes earlier. It's just a reminder what a tangent line is. A tangent is a line that intersects a circle in exactly one point, and a secant line is a line that intersects a circle in 2 points. Okay, so the radius is perpendicular to the tangent line. I have an example of a type of problem that you'll get with this relationship. All right, so PD is tangent to circle C, so line PD, or segment PD, is tangent to circle C. CD is equal to 5, so CD, this line right here, is equal to 5, so we'll draw that in. Okay, and PD, this little segment right here from PD, that is 3. What is the radius of the circle? Well, if you'll notice, we have a right triangle, and we have 2 sides, and we just need to find the third side. So the method for that is the Pythagorean Theorem. All right, so the Pythagorean Theorem says c squared equals a squared plus b squared. The square of the hypotenuse is equal to the sum of the squares of the legs. And our hypotenuse is always opposite the right angle, so that's going to be the 5. So 5 squared is equal to a squared. I'm just going to make the 3 the a and the r the b. All right, so 5 squared is 25, equals 9 plus r squared. I'm running out of room. And then I'm going to subtract 9 from both sides, and I get 16 equals r squared. When we have a side that's squared, to undo that, we take the square root. So we're going to take the square root of both sides, and we get r equals 4. In geometry, we're not going to, when we take the square root of 16, we get plus or minus 4. But in geometry, the radius is only going to be the positive 4. We have 4 scenarios when tangents and secants intersect. 3 of them are outside the circle and 1 on the inside of the circle. So let's go to the next page and do a sample. All right, so when we have 2 tangents and we have a circle that's divided into 2 arcs, it tells us that arc GF, so I go straight from G, the fastest way to get to F, and that would be 105. And then we want to find the measure of angle GEF. That would be this angle right here, G to E to F. Okay, so this angle right here. So we have that angle is what we're looking for. So X is equal to, we'll call that X, that angle X. It's equal to half of the big arc minus the small arc. Okay, so our small arc is 105. And we know that this angle has divided this into 2 arcs, this green one and the yellow one. So we know that the whole circle is 360, so 360 minus 105, and whatever we have left is going to be our big arc. So we've got 5, okay, so this is 255. So that's our big arc. So 255 minus 105 is going to be 150. So half of 150 is going to be our angle measure. So X is 75 degrees. Okay, this next example, we're given a tangent and a secant. It divides our circle into 2 arcs here, and then we have this left over. So this yellow arc is our big arc, and the green one is our small arc, and this angle out here is our angle. So we have, what is the measure of arc IJ is 105. So this is I straight to J. So the big arc is 105. Okay, and angle H is 42 degrees. So here's H, and so that's 42 degrees. And we want to figure out what the measure of arc I, or KI is. So from K to I is our X. All right, so we're going to fill out the formula. So we have our angle is 42 degrees, and that is equal to half of the big arc, which is 105, minus our small arc, and our small arc is our X. So here, to solve for X, I want to go ahead and multiply both sides by 2, because that way I can get rid of my fraction. And so I end up with 84 is equal to 105 minus X. And then I'm going to subtract 105 from both sides. I get negative 21 is going to equal negative X. So if I divide both sides by negative 1, I get X is equal to 21. So arc KI is 21 degrees. Here's another example when you have two secants. So this angle has divided the circle up into some arcs here. There's a small arc here and a big arc here. The big arc is always further away, and the small arc is always going to be the close one. Okay, so if arc MP is 45 degrees, and angle H is 20 degrees, oops, that should be angle L. If angle L is 20 degrees, I'll put a 20 right here, what is the measure of arc ON? So ON is this big arc here. So now we have our 3 pieces of information. We have one of them is a variable, and we're going to plug it into the formula. So angle is 20 equals half of the big arc, which is X, minus the small arc, which is 45. So again, when my variable's inside the parentheses, let's just go ahead and multiply both sides by 2. And that cancels out our fraction. So we end up with 40 is equal to X minus 45. So just doing the algebra, we add 45 to both sides, and we get 85 is X. So the measure of arc ON is 85 degrees. For this example, we have our 2 chords that cross inside the circle, and our angle is inside the circle. So we're going to use the plus sign for our formula. So let's look at what they've given us. So here's the measure of arc RS is 50 degrees, and arc TQ is 110 degrees. So what is the measure of angle TUQ? So starting at T, going to U, and then to Q, this angle right here is going to be our X. So we do the formula. X is equal to half of big arc plus the small arc. So we get half of 160 is 80. So our angle is 80 degrees. I hope this helped, and I hope that you got these equations. If you need to go back and rewind and pause, be sure to do that. And let me know if you need any help. You can always email me or text me. Thanks. Bye.